Touching circles. Two circles are said to be touching if they have only one point of intersection. To investigate whether two circles touch, we compare the distance between their centres with the sum or difference of their radii. Consider two circles of radius r1 and r2, where r1 is greater than r2, and let d be the distance between their centres. So circles touch externally. So here's circle 1, circle 2. We can see that they touch at one point only and they touch externally. They are outside of each other. So R1 is from the centre to the point at which they touch, and R2 is from its centre to the point at which they touch. And adding these together gives us the distance between the centres. So D, the distance between the centres, is equal to R1 plus R2. The distance between their centres is equal to the sum of their radii. Here we have circles touching internally. So we have a larger circle and another circle inside the larger circle, and they are touching at this point, so they are touching internally. So the radius of the smaller circle is R2, the radius of the larger circle is R1, and the distance between the centres is D. So D, the distance between the centres, is equal to radius 1 minus radius 2. So D, the distance between the centres, is equal to R1 take by R2. So the distance between their centres is equal to the difference of their radii. S, x squared plus y squared minus 16y plus 32 equals 0, and K, x squared plus y squared minus 18x plus 2y plus 32 is equal to 0, are two circles. Show that the circles touch externally and find their point of contact. So there is no x term for the first circle, so we could say it's 0x, and half of 0 changing the sign still just gives us 0. And the y term is minus 16, so half of that and change the sign we get 8, so the centre is 0, 8 for the first circle. And then putting it into the radius formula, we have the square root of 0 squared plus 8 squared minus 32. So the C is 32. And this gives us 4 root 2, which is R1, radius 1. Taking the second circle, the x term is minus 18x, so half of that changes sign gives us 9. We're dividing by minus 2, that's the same thing. And then the y term is 2, so half of that changes sign gives us minus 1. So the centre of the second circle is 9 minus 1. And then into the radius formula, using 32 for the C, we have the square root of 9 squared plus minus 1 to be squared minus 32, which gives us 5 root 2. So R2, radius 2, is 5 root 2. So next we want to get the distance between the centres. So the centre of the first circle is 0, 8. The centre of the second circle is 9 minus 1. So we label them x1, y1, x2, y2, and sub into the distance formula. So subbing into the distance formula, to get the distance between the centres, we get 9 root 2. Thus, the circles touch externally as 4 root 2, which is the radius of circle 1, plus 5 root 2, which is the radius of circle 2, is equal to 9 root 2, which is the distance between the centres. So R1 plus R2 is equal to the distance between C1 and C2, where C1 and C2 are the centres. So we can see it in the diagram. Here's circle S, centre 0, 8. Here's circle K, centre 9 minus 1. They're touching externally. This radius is 4 root 2. This radius is 5 root 2. And adding them together gives us the distance between the centres, which is 9 root 2. To determine the point of contact, divide the line segment, joining the centres in the ratio of 4 to 5. Because remember, radius 1 is 4 root 2, radius 2 is 5 root 2. So 4 root 2 and 5 root 2. So we can break it up in the ratio of 4 to 5. So let the point of contact be x comma y, this point of contact here. So we know that the centre of the first circle is 0, 8, so that's C1. The centre of the second circle is 9 minus 1, so that's C2. And the point of contact is here, x comma y. So to determine the point of contact, divide the line segment joining the centres in the ratio of 4 to 5, let the point of contact be x comma y. So that's what we had on the previous slide. So let's start with the x terms. So for circle 1, the x term is 0. And for circle 2, the x term is 9. So x minus 0, so x minus 0 is equal to 4. And 9 minus x, so 9 minus x is equal to 5. So x minus 0 is equal to 4, x minus 0 is equal to 4, and 9 minus x is equal to 5. 9 minus x is equal to 5. So now we cross multiply, so we get 5x equals 4 times 9 minus x, which gives us 5x, which equals 36 minus 4x. So 9x is equal to 36, so x is equal to 4. So the x term is 4 for our point of contact. Now we take the y term. So the y term for the centre of circle 1 is 8, and the y term for the centre of circle 2 is minus 1. So y minus 8 is equal to 4. So y minus 8 is equal to 4. And minus 1 minus y is equal to 5. So minus 1 minus y is equal to 5. Now we cross multiply. So we multiply out the brackets, we simplify, and we get y is equal to 4. So the y term for our point of contact is 4. So the point of contact is 4, 4. So this point of contact here is 4, 4. Okay, so this is method 2 using the formula. So this is the formula for the point dividing a line segment in the ratio a to b. So we already know that the ratio is 4 to 5. So we have our formula from our formula book. We need to figure out what's the a and the b. So the a is 4, and the b is 5 because it's in the ratio of 4 to 5. And then we have to figure out what's our x1, y1, x2, y2. So we label our centre as x1, y1, centre of C1, and our centre of C2 as x2, y2. Sub into the formula, multiply out, simplify, and again we get 4, 4. So again the point of contact is 4, 4. So you can see in our diagram that the point of contact is indeed 4, 4. Chords of circle. Circles intersecting the axes. To find where a circle intersects the axes, we use the following. The circle intersects the x-axis at y is equal to 0. The circle intersects the y-axis at x is equal to 0. So here's our x-axis. Here's our y-axis. We can see the circle is intersecting both of them. So it intersects the x-axis at y is equal to 0. And it intersects the y-axis at x is equal to 0. Find the coordinates of the points where the circle x squared plus y squared plus 4x minus 4y minus 5 equals 0 intersects the x-axis and the y-axis. So we take our equation x squared plus y squared plus 4x minus 4y minus 5 is equal to 0. On the x-axis, y is equal to 0, so we put in y is equal to 0. So we swap each of those y's for 0, so they pretty much just cancel out. So we end up with x squared plus 4x minus 5 is equal to 0. We factorise and we solve. So if x is equal to minus 5 and y is equal to 0, then our coordinate is minus 5, 0. And if x is equal to 1 and y is equal to 0, then our other coordinate is 1, 0. So these are the coordinates on the x-axis where our circle intersects the x-axis. So likewise then for the y-axis. So on the y-axis, x is equal to 0. So we put in x is equal to 0. So we swap all of our x's for 0, so the x's basically just cancel out. So we end up with y squared minus 4y minus 5 is equal to 0. We factorise and we solve. So if y is equal to minus 1, x is equal to 0, then one point is 0 minus 1. If y is equal to 5, x is equal to 0, then another point is 0, 5. So these are the coordinates on the y-axis where the circle intersects the y-axis. Common chord or common tangent. If S1 equals 0 and S2 equals 0 are the equations of two circles in standard form, then S1 minus S2 is equal to 0 is the equation of the common chord or common tangent of the two circles. So for a common chord, here we see a chord. So a chord is a section of a secant. So it just goes from one side of the circle to the other side. So similar to a diameter, but doesn't go through the centre. So S1 minus S2 is equal to 0. So 2 points of intersection. So for a common tangent, we see we have a common tangent there. So again, S1 minus S2 is equal to 0, and we have 1 point of intersection. Note, to find the equation of the common chord or common tangent of two circles S1 equals 0 and S2 equals 0, the coefficients of x squared and y squared must be the same for both circles. To find the coordinates of the points of intersection of the two circles, do the following. Step 1, find the equation of the common chord, so S1 minus S2 equals 0. Step 2, solve between the equation of the common chord and the equation of one of the circles. So the circles x squared plus y squared minus 6x plus 4y minus 7 equals 0, and x squared plus y squared minus 16x minus 16y plus 63 equals 0 intersect at the points P and Q. Find the equation of the line PQ. So the equation of the line PQ is given by S1 minus S2 is equal to 0. So this is S1, we write in our minus, and then this is S2. It's important to use brackets so that you can multiply the minus into each term. So we just bring down the yellow equation and then multiply in the minus into each of these terms. Then we simplify and we end up with x plus y minus 7 equals 0. Thus the equation of the line PQ, the common chord, is x plus y minus 7 equals 0. Note, to find the coordinates of P and Q, solve between the equations. So x plus y minus 7 equals 0, and either x squared plus y squared minus 6x plus 4y minus 7 equals 0, so that was our first circle, or x squared plus y squared minus 16x minus 6y plus 63 equals 0, which was our second circle. Radius perpendicular to a chord. A radius, or part of a radius, that is perpendicular to a chord bisects that chord. Bisects means to cut in half. This also enables us to use Pythagoras' theorem. So Pythagoras' theorem we know to be c squared equals a squared plus b squared, where c is the longest side. But we can actually rewrite it as r squared equals d squared plus x squared, where r is the radius, so the radius would be the hypotenuse. D would be the perpendicular distance between the point and the chord, and x would be the other side of the right angle triangle. Thus, knowing 2 of the d, x and r, we can find the third. So remember that a chord is bisected, which means cut in half, by the radius or part of the radius. So this length x is equal to this length x. A circle C has a centre 2 minus 3 and makes a chord of 8 root 2 units on the y-axis. Find the equation of C. A rough diagram is very useful. So here we have our circle. Here we have our x-axis and our y-axis, our centre 2, 3, and our radius we just label as r, and the chord goes from this point down to this point and is 8 root 2 units. So from here to here must be 4 root 2 units. We have a centre and we require the radius. The length of the perpendicular from the centre 2, 3 to the y-axis is 2. So if this is the centre 2, 3, then this must be 2 on the x-axis. So therefore from here to here must be 2 units. So from here to here must be 2 units. The length of the chord on the y-axis is 8 root 2, and 8 root 2 divided by 2 is 4 root 2, so again that's where we get the 4 root 2 from. The perpendicular from the centre bisects the chord, thus this length is 4 root 2. Remember, bisect means cut in half. So using Pythagoras' theorem, c squared equals a squared plus b squared. So c is r, the longest side, which is also the radius. A is 4 root 2, b is 2. So we end up with r squared equals 4 root 2 squared plus 2 squared, which gives us 32 plus 4, which is 36. And the square root of 36 is 6, so r is equal to 6. So the radius is 6. Remember, we're looking for the equation of the circle. We have the radius now, and we have the centre. So we use our equation, which is x minus h to be squared plus y minus k to be squared equals r squared. Swap the h for 2, the k for 3, and the r for 6. And 6 squared is 36, so our equation is x minus 2 to be squared plus y minus 3b squared equals 36, or multiplying out the brackets, x squared plus y squared minus 4x minus 6y minus 23 is equal to 0.